There we go. We're back. We did it. We're back. We're live. So for those of you who just joined, we were on the we did a little interview for the old podcast there just a minute ago. But I really wanted to see what Tom and Lee here were working on to sort of better integrate with Spring, and what it looks like to use WireMock and WireMock Cloud, and all this good stuff. And they promised they wouldn't mind doing a demo for us. So please welcome back. Lee and Tom. Somebody got the first medal first. What does that mean? Yes. Well, hi. Welcome. So great. Okay. So do you want to share your screen, and I can throw it up here on the?
Well, okay. Let's have a look.
Oh, the sun is now coming. Sun's over there, but it's beaming off of a building, which is reflecting straight in my eyeballs. So if you see me bleeding out of my right eye, you'll know why. It's like Chronicles of Riddick. Okay, folks, can you all see? Can everybody see? By the way, what does this do? Oh, no, I want that one. Okay, yeah. Everybody can see the thing there.
Okay, is that big enough? I think that's as much as I can zoom in at the moment. Is that?
Yeah, it looks fine. You in Windows or Mac or Linux?
I'm on a Mac at the moment.
Nice. Crisp fonts.
Cool. So what this is going to demo is, I guess, the kind of classic WireMock use case. You have a service that communicates out to an external API, and you want to be able to mock that to do some testing. So this little Spring service that we've got here talks to the People in Space API. So I think should be able to show that. So it's the opennotify.org
What is that?
API.
Oh, just literally like astrology, that kind of stuff. Okay.
Yeah, the people who are currently in space. So you can see here that the API returns the names and what craft they're currently on. Heroes. So all this service does is it pulls all that data and it returns exactly the same data, but just the names with the craft in brackets next to it. Nothing kind of crazy. And we do that very much, I guess. Most people watching or listening to this will kind of understand with a Spring client, where we kind of specify the endpoint that we're talking to, and that's configured in the properties file, and we're kind of good to go. We've got the controllers and the services and things like that. So if I just start this up quickly, and we can see what happens when it talks to the real endpoint.
This is nice.
So as you can see, we've got all the same names, but they're just bunched together with the craft next to it. So the question comes, how do I test this without constantly talking to the external world? And how do I make sure that I can test cases like what happens if there's nobody currently in space at the moment, or what happens if their endpoint returns an error, and things like that. So this is where the new WireMock Spring integration comes in. And this test is going to show you a couple of things that we spoke about previously, the WireMock JSON, and how you can use the Java DSL to kind of configure it as well. So this test is a Spring Boot test, as I'm sure everybody's familiar with. But the real nice part of this integration is where we get this bit here, the enable WireMock. So the configuration, we're basically just saying we want to stub out the OpenNotify client, and most importantly here, this base URL property is the property that we configure in our application properties. So we're effectively saying, instead of calling out to api.opennotify.org, we're going to replace that in our tests with the WireMock base URL. And I guess important to note here that we're not we're not seeing anything about ports or anything like that. So WireMock will spin up on a random port, which means that you can run your tests in parallel and greatly reduce the risk of kind of port clashes and things like that. So you can see here that we've specified this thing called files under class path, which basically references this directory in the test resources here. WireMock has a standard directory structure where your WireMock JSON files go into the mappings directory. So you can see here that we've got a WireMock JSON file. Now, again, this is very simple. We're basically saying for anything that comes in for this request at this endpoint as a GET, we want to return a status of 200, and we want to return a JSON body that matches what we would have got from the real endpoint. But in this case, we've just got three names, so we can tell the difference between the real one and our test one. So this is the JSON format for WireMock, but it really doesn't even go into all of the things you can do in there. We could have specified that it returns an error either via a status code or just a bad response, a bad network response or something like that. And at the moment, this is all static data. We could have used the handlebars templating to do a dynamic response to this if we wanted to. But for the purposes of this, we're just going to go with a static response. So this test that you can see here basically just calls out to our services endpoint, the v1 people in space, and validates that it gets back the 200. It then deserializes the response, and it just checks that the names that we expect to be there are there. And that's doing that because WireMock is spinning up in the background. As you can see here, we've injected a WireMock server for the Open Notify client, and it's loading in the JSON mapping file and then returning the response. So very, very cool.
Yeah.
The test that we have down here demonstrates the other way of configuring WireMock stubs. Instead of the JSON, we use the kind of WireMock DSL. So you can say for a GET request to this endpoint, I want to return a response with the application JSON content type. But in this instance, I don't want any names. Basically, we're saying currently there's nobody in space. So when I call this endpoint, I expect to get a list of people that has size 0. So we can run these. If I can, looks like IntelliJ's frozen. Just bear with me. Okay.
Let me guess, you've been running it for like a week, and it
it doesn't get shut down very often, I have to say. So we spin up the tests, and as you can see, they run really quickly. WireMock spins up, loads the JSON, all gets configured, and then shuts down again. Now this configure WireMock uses has been updated to use the Jetty 12 version of WireMock, which was actually prompted quite a bit by the 3.x releases of Spring. Obviously, Spring is one of the community that's pretty big in terms of WireMock usage, and originally we were using Jetty 11 in WireMock, which clashed when the Spring team updated Spring Boot to use Jetty 12. So this has been updated to work seamlessly with all of the 3.x releases of Spring.
Nice. Oh, and 4.0 is coming out later this year, so that'll be fun. Spring Boot 3.0.
Yeah, absolutely. So, and that's a very simple kind of WireMock Spring use case. Just a few simple annotations and configuration options, and you can completely mock out the endpoints that you're using in a way that is very seamless and familiar to kind of Spring users as a whole.
One thing I'd like to add to this, so the library that Lee's just demonstrated is an integration library that's it's not part of WireMock core. It's a separate Spring integration library. It wasn't built by us originally. It was actually built by a very sort of active and prolific Spring community member, Maciej Łakowiak, who I'm sure you must know.
Love him.
So he built it originally, and he was kind enough to donate it into the WireMock organization. So he occasionally still dips in and out and helps us out with it. And there's another regular WireMock contributor called Thomas Burr, who helped with the migration and helps maintain it and so on like that. So just wanting to give credit where it's due.
Totally, yeah.
Amazing. Sure. Maciej has been on the podcast as well. And we got some questions here, by the way. Can this be used for real-time notifications? To mock it out? I don't know. And I don't know. I'm not sure if this is about WireMock in specific or just general architecture questions. If it's the latter, then yes, you could use WebSockets for real-time notifications. But does WireMock support WebSockets?
So it doesn't at the moment, and this is something I would absolutely love to find the time to work on. We've been kicking around endlessly sort of architectural ideas. I think we have a pretty good idea in general how we would want to do kind of asynchronous mocking. I think with it's a far more complex model when you go into sort of async protocols like WebSockets or messaging protocols or actually even doing sort of server-sent events properly has its sort of share of additional complexity, because messages can be sent not triggered by anything. You can have one inbound event sort of triggering a whole load of outbound events. You can sort of do cross triggers, so an HTTP request comes in and that triggers a WebSocket message, and so there's quite a lot of sort of fundamental replumbing that I think we're going to need to do in order to really enable people to kind of do this stuff the WireMock way. But we definitely want to work on that. It's just finding the bandwidth to do it at the moment has been challenging.
Super cool, super good. Okay, wow. Okay, so that integration is that. I was just gonna say now that you said it's Maciej, like I was looking at it going, that feels really idiomatic. Like it was built somebody who really, did the homework assignment. Now I know why. He's also the lead of Spring Cloud AWS, right? Which is
yes, of course he is. Yeah.
So
I mean, I suppose a couple of observations about this integration, because there is a built-in JUnit 4 and JUnit 5 extension that you can also use with WireMock. And the reason this Spring integration library exists, and the reason it's probably preferable to use if you're building Spring Boot apps in particular, is first of all, as Lee mentioned, it allows you to randomize the port numbers, which is kind of tricky if you're not using an extension that knows about Spring, because you need to be able to inject random port numbers into kind of base URLs and configuration. So the idea is that you want when your app boots up in with the environment settings it's using for your integration tests, then it needs to get wired up to whatever WireMock instances it's started. And typically when you use the JUnit extension, you kind of end up resorting to fixing the port numbers. And that means you can't do concurrent testing. And it also kind of means that you, on some sort of shared tenancy CI systems, you kind of get into difficulties if multiple processes are trying to bind to the same ports. So that's quite a big deal. There was a thing added recently as well, which also exposes WireMock as a Java bean. And there was a developer who published a blog post about trying to get Cucumber JVM working with WireMock and Spring, and was struggling to get the integration working, and so discarded that and ended up kind of pasting it together himself. And so we sort of started talking about how can we make this work the right way, and it ended up being a case of just adding a Spring bean with WireMock so that it could then be injected into step definitions in Cucumber JVM. Amazing.
Okay, this kind of stuff is so good. Look at that. It's I have another question unrelated to this. Are you team auto? Like, is it night mode in your IDE because it's nighttime where you are, and is it daytime during the day?
Me personally,
Wait,
I mean, this is the JetBrains kind of dark purple theme,
right.
and that's what stays all the time on my IDE.
Okay. I was dark mode for live for a while, and I've recently started doing during the daytime. It's in like I use my Mac. I have IntelliJ Sync for the operating system, and then the operating system changes based on the time of day, and so IntelliJ syncs as well. And it's just I was just wondering if you kept it like this all day. I don't know. I was dark mode for years, just all day and night. Didn't matter if I was right in front of the sun. You know, I wanted to stare into a dark screen.
Sure.
And I don't know, just okay, whatever. Anyway, great. This is super good. So this is a WireMock, and it's a natural integration with testing. Obviously, testing. You know, you've got one or two tests here, but as soon as you've got a number of different teams, a number of different things that are changing, and all that, you're going to have scalability issues. And I think WireMock Cloud is a really great way to sort of mitigate a lot of that, right?
Yeah, absolutely. That's when you might kind of decide to kind of make the jump from kind of WireMock in what the form that we've seen here to kind of some external tools like WireMock Cloud. But this is, I guess, what we talked about before around the different protocols. This is your classic REST integrations, and I think Tom's got a really nice demo around how you can use the same Spring integration with gRPC and mocking gRPC endpoints.
How can I try we should do a separate thing when we get a chance, because the gRPC stuff is, we have this new nascent experimental project called Spring gRPC, and you know, exactly the same thing. I want to be able to build gRPC services and controllers and all that, and then mock out the dependencies, these satellite dependencies. Yeah, that's good.
Yeah. Do you want to jump on that demo, Tom? Shall I?
Yeah, I can do that. If we've got time to do that and the other one as well, then I can jump straight in. I mean, it builds on what Lee's already demonstrated, so I can sort of skip over a lot of it and sort of straight into the gRPC part. So hopefully it won't be too onerous. Let's see. Do I have the ability to share my screen? Is the question. Now then, let's go for that one. Okay, can you see my IDE?
Yeah, brilliant. Yep.
Excellent. Yeah. Okay. So this is a demo project, by the way. This is on our on the WireMock GitHub organization. There's a project called WireMock gRPC demos, which has got this Spring demo and a handful of others that kind of wire things up in different ways. It's a pretty straightforward project. It has a single, very simple proto file describing this this echo service that just sort of echoes a message from request and response. There are some projects with more complex gRPC setups with sort of multiple proto files and all that kind of stuff also in that project. But I wanted to keep this one nice and simple just to kind of prove the concept. So there's a proto definition for a service. This is a service that our Spring project depends on. There's the Spring project itself just has a simple controller in it, and essentially it takes a REST request on the way in. So our test is going to be kind of driving the REST interface on our own service, and then our service is going to be calling out to a gRPC service to actually do the work, and the gRPC service is the one that we want to mock, so we can run a test of our own Spring application and kind of isolate it from its external dependencies. What else is significant about this? So the test resources. This is wiring up our. This is where the binding between the sort of the dynamic port that's assigned to WireMock to our Spring configuration and test is done. So whatever port number it comes up on this echo service that we're creating, it will get wired in. We have a Gradle build file with the sort of gRPC protoc stuff in it. It's generating two sets of artifacts. This is probably worth explaining. So it generates the Java source files into as you would typically with a gRPC project, but we're also generating this file here, services.dsc. So this is a kind of I guess, language neutral sort of binary format for describing gRPC services. And this is what WireMock needs to use, because WireMock is kind of dynamic, because you can stub anything you like. It can't really be done with static code. It needs to be done dynamically. So we need a dynamic definition for it to read, or just a sort of data description of the service that it can read and then dynamically kind of respond to. So that's for WireMock. But as we'll see, we also use the generated Java as kind of an affordance in our test configuration. So if we go and look at our test case now, I'll go through it sort of bit by bit. Some of this will be familiar from Lee's demonstrations. Also, we have the Spring Boot test stuff in there, completely straightforward. We have a single WireMock instance configured, again, as before, which we're naming, and where we're exposing this port property, the one we used in our application properties. This is something hasn't been shown yet. So the gRPC functionality in WireMock is an extension. It's a separate jar file. And so we need to pass this extension factory into the extension factories collection, and that will do all of the work and kind of adapting WireMock to work with gRPC. gRPC is kind of uniquely difficult in some way. It's HTTP2 only, and it uses HTTP2 in quite an idiosyncratic way, I guess you could say. So right. This actually requires some quite kind of low-level wrangling of Jetty and so on in order to make it work. It wasn't as simple as the difference between SOAP and REST, for instance.
Can you zoom in a little bit? I'm getting a nice request from the users.
Sure, no problem. Let me adjust that. Okay, is that a bit more readable?
Yeah, for me it is. I hope it is for the audience. I had no problems the first time.
Great. Okay, so we're injecting a WireMock instance as before. And then this thing here is where we start getting into the sort of gRPC specific stuff. So gRPC has the notion of services, and services have methods. And the way we work with it within WireMock is we wrap one of these service classes around a named service, and that becomes the kind of entry point for the sort of extended WireMock DSL that we can use to configure gRPC responses. So this is what we're doing here. We're saying we're going to use this service name, just use the constant from the generated class. So if we regenerate our proto files, then no problem. And then we can use this, as I say, as the entry point for stubbing. So I've got a couple of tests here that demonstrate a couple of different approaches you can take to defining WireMock stubs. So one is using the generated Java classes. So as I mentioned before, when we do generate proto on our project, it spits out a load of Java classes. So the protobuf compiler is really good actually in this regard. It produces really nice usable domain classes and good builders and so on like that. So it's nice to work with. And so we take advantage of that here, and we say that you can use those builders directly when building mocked responses. And obviously the great thing about this is it's type safe. It means that if you change anything in the proto file that breaks the mock, then the compiler will tell you about it immediately. You don't have to wait until you run your tests in order to figure that out. So you can do that, and if you want to do things which are entirely sort of static and structured around your DSL, then this is a great way of doing it. And like I say, it will probably reduce your maintenance burden over time because of the type safety. But there is an alternative as well. So the way everything works with this plugin is it kind of, I guess, sort of normalizes everything into posted JSON. So a gRPC request comes into WireMock, it gets converted into a post request with a JSON body with the sort of the JSON serialized equivalent of the protobuf message. And so that means we can do all of the things within WireMock that we can do with the REST API. We can essentially construct dynamically a JSON response, and as long as it conforms to our protobuf message, then it will get serialized back into protobuf on the way out. So what this one is doing here is it's dynamically it's using this handlebars helper to extract the message from the request and templating it into the body. So whatever we put into the request sort of comes out the other end. So I can run this, and we're passing in my message here, and then we're asserting it's my message down there. And if my IntelliJ doesn't decide to lock up now, oh, there we go. So we run the server, and that's passed. But if I now change this to the wrong message and run it again, then we should get a test failure. With any luck. Yes, good.
Wow.
And you see it says wrong message coming out. So this is the result of that dynamic templating. So that's kind of it in a nutshell. There's a little bit more to it in terms of there's some limited support for streaming requests and responses. This is something actually that fits into this broader story about doing asynchronous mocking properly, being able to deal with kind of multi-message responses and so on like that.
Right.
It will do it kind of basically. So if you've got a streamed response, then it will you can give it essentially all the messages in the you can give it a single message and it will return that as a stream. So it will be valid with respect to the design of the API, but maybe not all that useful in some testing circumstances. But you can at least do it.
Wow, oh, that's so cool. This is like, I mean, this is literally just something I've had on my mind. Just recently we got this new project. Like I said, this is super. Couldn't have happened. Couldn't have. This landed in my lap at the perfect time. I cannot tell you how grateful I am for the gRPC stuff you've just showed me. That's wow. Okay.
Oh, that's great news. Well, I mean, we'd love to see more people using it and get more feedback on it. So that's great. Needless to say, this is built into cloud as well, so you can go and build, sort of edit your gRPC mock API from within the editor in cloud.
Do you want to show us the cloud stuff? I'm kind of itching to see that. Like I just.
Oh yeah, absolutely.
You don't have to if you don't want to, but I really want to kind of see.
No, you don't have to give me much encouragement to show this off.
Oh.
So like I say, it's a SaaS product. You can run it on Kubernetes as well, but most people use it from just our SaaS hosted version. I have this long list of all these different mock APIs I've created over time. You can create REST. You can create gRPC. Like I say, there's kind of an unstructured type, which is just sort of a bag of HTTP that's not any particular style. You can create SOAP APIs that way. And you very soon there's going to be GraphQL support as well. I thought, there's lots of different things I could demo. I think we talked a little bit about prototyping and the kind of the open API workflow. So I thought I'd kind of open with that and see how we go. So if I go and I think this is an empty API. There we go. So this is an empty mock API. There's a whole bunch of ways that I can build an API. I'll just show you this quickly. So you can import from a bunch of different formats. Open API, a Harlog that you can export from your browser and various other tools, or Postman collection if you're using Postman, and that will generate a mock API. So you can start from that, or like I say, you can start in this editing view and you can build things up. Sort of from scratch, and you can play around with the design and kind of work that way. And that's how we've seen some teams use this, is that they will put this up on a projector in a sort of co-design session, and they'll just kind of kick around the configuration of the stubs until they've got the design that they want, and then they leave, and the mock becomes the reference. So I'll give you a quick demo of that and show you how it all hangs together. So I'm going to do I'm just going to do a sort of single endpoint. So imagine this is a sort of a payments API of some kind, a sort of Stripe-like API, maybe an internal microservice that we want to build, and we want to start with an endpoint that creates a new charge.
Are you bringing up Stripe because it's so uniquely painful, or is it?
No, actually, Stripe Sandbox is better than most. I think it's just a very recognizable API. I think it's they sort of in API circles seem to be considered one of the kind of standard bearers for the early pioneers for sort of great developer experience around APIs, or building an API first business,
right?
And kind of attracting developers as the kind of primary audience by creating a great DX for their API. So I think they probably things have probably moved on a bit since sort of Stripe were in pole position, but they actually have pretty good DX, and they have a good sandbox. I mean, that's not to say we still mock, we use Stripe as our payment provider, and we still mock it with WireMock, just because apart from anything else, it's many times faster to integrate with the mock. Like we say, when you're running CI jobs many times a day, the difference between a real hosted sandbox and a mock in terms of speed is becomes very noticeable.
Yeah, this is one of those things. I mean, increasingly we're seeing. I don't know how you exist on the internet today without having an API component to it. And you know how you can tell that's true? Look for all the developer advocates like myself that exist now, right? Every company has an API, even if it's internal. So you have people that are whose job it is, whose remit it is to socialize that API to make it so that others can build upon it, right? And so when you see that being true, you start to realize, okay, things like this invaluable, right?
Yeah, absolutely. I mean, APIs are the sort of the primary face of an increasing number of products and companies. That, you know, there are lots of companies whose API is literally the way they sell their products. And you look at there are organizations, you know, who have been doing microservices for a long time. I mean, we've been talking to companies recently who have 2,500 microservices. There was one that had over 6,000 microservices, and each one of these has an API. You know, this is how they all interact with each other. Some of them have asynchronous APIs, message-based ones, but they have an API of some kind.
Yeah.
And, you know, so the number of APIs you might potentially be exposed to if you're in a sort of largish organization as a developer is enormous. And there was another example I heard of. I think it was in the same organization that had 2,500 microservices. The engineer that we were talking to was saying that there was one service he'd worked on, and he didn't think this was particularly unusual, that itself depended on over 100 other services. You know, had 100 outbound API connections to other services, and the work involved in making that project kind of operable and you know, sort of usable as a developer and testable was enormous. And the reason they were speaking to us because they had really acute problems of scale just to do with that degree of interconnectedness of their services.
Nice. Wow. I mean, and you're right. 100. That makes me itch just thinking about having to stand up 100. Even 100 mocks feels like that would be quite the lift on every startup, you know.
Whoa. Yes. Yeah. I mean, that's the extreme end of the scale, but this is a real company doing real work, and I'm sure there are others out there that have a similar scale of problem.
They're just the ones who are honest. Yeah, but yeah, more power to you. If it's working, then it's working. Don't knock production. I'm just saying, sounds intense.
Yeah, absolutely.
Super cool. So where do people go and sign up for WireMock Cloud? Is that a thing, or is there like?
So if you go to wiremock.io, there's a get started for free button on there, and you can sign up with GitHub SSO or Google or your email address. It's very straightforward. Let me just very quickly run through the prototyping workflow. I think that might be the one that's quite interesting. So we were talking about we want to build a kind of a payments API where you can create a new charge on behalf of a customer. So I can create stubs just through this sort of editing view by clicking new stub. And we might want to say that this is the create charge endpoint. So we'll give it a name, and we'll say it's post, because this is kind of the way you do things in REST, posting to a charges collection. And one I made earlier, so I don't have to type it out. So this is an example of what a body might look like. So we've got a JSON request body with the amount, currency, and the customer that we're creating the charge for. And then similarly in the response, again, this is a very, very typical REST pattern where you have a set of data that is in the request, and then the response and the state that gets created is kind of the whatever you sent it plus a load of kind of synthesized stuff or a bunch of transform stuff. So we have pretty much the same data there, but we've got a generated ID, and we've got creation date and status and so on like that. So if I hit save on this stub now, I can go and make a little test request. This is a sort of simple inbuilt kind of HTTP client that just lets you test things. Obviously, this is pretty trivial. I kind of knew that I was going to get that result. This is more useful when you're templating, doing dynamic responses, or when you're doing complex matching, because then, actually it's you do want to make sure that you're getting the response you expect. But anyway, this stub is clearly working. So now I can head over to the Open API tab. So in the REST mock API type, you get this extra Open API page, and you can see it's generated Open API, and this is just based on the examples I've given. I haven't had to kind of construct that in a design tool or handwrite it or anything like that. And the really nice thing about this is that we also get generated documentation. So I can go into this sort of documentation page for the endpoint I've just created. I can also make a test request through the documentation pages. And like I say, what this really facilitates is this easy collaboration between consumers and producers. So everybody who's a kind of stakeholder to an API design can sit on a virtual or real meeting room and collaborate around mocks. And obviously they're very easy to create, they're very easy to edit, and you immediately get a specification document and documentation that everybody can walk away with. And it kind of means everybody has this quite precise, sort of unambiguous view of what are we supposed to be building against if we're a consumer, or what are we supposed to be building if we're ultimately the producer of this API functionality.
And it lets you iterate. This is so good. This is like documentational almost. It's not just a technical artifact. This gives me the ability to poke and prod and manipulate, try, before writing code.
Yeah, exactly. And in fact, actually, I'll point this out because it's just a cool thing that we did recently that I really like. Is you can now get it. So we recently added this stateful mocking feature. So mocks are stateless by default. They typically the response that you get back is entirely a function of the request, and there can be some complexity to that. There can be some complex matching logic. There can be sort of dynamic behavior in the response, but fundamentally you give it the same request and you'll get the same response back. But there are situations where you need to go a bit beyond that, where you need to model a certain amount of statefulness. So I create a charge and it goes into a charge collection, and I can go and retrieve that later. Or I create a token of some kind. If it's a sort of auth type flow, then I want to be able to create a token and then validate it later or consume it in some way later on in a flow. And I need that value that was sort of created or sent in the first place to kind of match the one later on. So having purely canned data in that situation doesn't really cut it. The other reason that statefulness can be useful is if you're doing things like exploratory testing or product demos, then things kind of look weird if state doesn't get updated when you interact with an app. Whereas if you hit save on something and it does actually update the page, then that's a far better experience. And particularly if you're sort of demoing to kind of non-technical stakeholders who might not quite grok the idea that, our mocks are stateless, and so that's the only reason that apparently this page doesn't work properly. So what we did was we added this. In fact, let me just quickly do this because it works quite well with this demo I've just done. I'm going to wipe all this Open API stuff out, and I'm going to click this. So this is kind of a generator where you give it the sort of base URL for the collection. So actually, I can just say charges like this. This is essentially the post URL. So I'm pretty much taking what I just did, but feeding it into this generator. Yeah. I can do the request and the response examples like this. So like I say, this is really the state that gets constructed. So it will come back in the post, but it will also come back when you make a GET request and that kind of thing.
Right.
It will generate a whole bunch of these different stubs. If I do that,
wow,
voila. And again, it's generated all the Open API, so I can go in here, and now I've got all these endpoints generated just from that pair of examples. And the really cool thing about this is that, like I say, it's stateful. So if I say, get me my charges, I get nothing back because I haven't created anything yet. But now I can go in and say, create this charge, maybe let's create something in US dollars as well. And both of those have been created. And now I can go and fetch them, and now they're returned in my collection. And I can do something like go and grab an individual ID. I can say, go and get me just one of them by ID, all of that. And then if I want, I can go and blow them all away by doing a delete all. And we're back to square one. So this kind of enables this kind of elevated degree of realism in our mock API.
Is there a free tier for WireMock Cloud to test things out? Asks.
Yes, there is. Yeah, there's a free forever tier, which is functionally you basically get everything that you get as a paying customer, but you're limited to 1,000 requests a month. When you initially sign up, you get put onto an enterprise trial. So initially, you get in the first month you get 10,000 requests and some other capabilities like the ability to build teams and so on like that. And then if you don't upgrade and become a paid customer, then you drop down to the sort of individual free forever tier. But yeah, that is indefinite, and your quota kind of resets at the end of every month.
And well, that's amazing. Wait, so what if somebody has like the Salesforce API and it's like 1,000 different JSON stanzas or something like that? You know, like what is there a limit on the payload size, or is it just requests flat? There's no.
So yeah, so I mean, there are some. We have to put some practical limits on payload sizes and so on like that. Obviously, when you're providing cloud services, if you leave things completely unconstrained, then sooner or later somebody comes along and uploads a sort of gigabyte file and causes you problems. So we do have some limits in place. They're fairly large. They tend not to be a problem for anybody not doing anything kind of quite extreme. I think if I remember rightly, on the individual plan, we limit you to 500 stub definitions inside an API at the moment, which is
good.
It's if you're creating them by hand, is usually far more than you need. The main reason the numbers as high as it is actually is because occasionally people will bring quite big open API documents and import them, and that will generate lots and lots of stubs. And so we sort of try within reason to give you a good experience when you first sign up when you're importing open API. Open API is an interesting one. There are some really, really big, complex open API documents out there, and actually it's quite a large and complex problem, sort of mapping between mocks and those, far more so than you'd think, sort of at first sight. And there's this. I'm going to this whole sidebar about this, which I won't elaborate on too much, but there's an interesting sort of problem about that. There's no format that has complete information. There are things that mocks describe that OpenAPI doesn't, but there are things that OpenAPI describes that mocks don't.
Oh yeah.
And actually, it's only the part of the reason we kind of maintain both sets of information. So you have the OpenAPI and the stubs side by side, is because there's this sort of structural description is all in the OpenAPI, and the behavioral descriptions are all in the mock. And there are lots of tools out there that will generate mocks from OpenAPI, but kind of they stop at that point, and you really can't really describe the sort of breadth and richness of an API's behavior when you do that, because OpenAPI is just not designed to describe that. So this is one of the things that we're trying to tackle is giving you the best of both worlds. The ability to work with sort of syntactic or structural contracts like OpenAPI, but then also express kind of richness of behavior like statefulness or the matching system. I mean, this is the same set of matches that you get in the open source.
Right.
But, you can sort of build them up, and I can do kind of compositions of and or and all that kind of thing. And by doing that, you can build in business rules. So there's another demo I give, which is this sort of train travel app, where there's a date query parameter you pass in when you're searching for train trips, and if it's in the future, then it works fine because you probably want to book a train ticket in the future. But then if you try and set it in the past, then you get a completely different error response. And that's a fairly trivial example, but it's an example of where there's kind of business logic being expressed, and where, like I say, there isn't a standard way within OpenAPI to express those kinds of things.
Wow!
So we're trying to find a way of sort of bringing those two things together. That's a big part of what this is doing.
Sign me up. I love it. Really, really good.
I mean, please do. We'd love to get your feedback. I probably won't. Hang on. I'll save this and then leave. Yeah. If we go into the OpenAPI very briefly, so there's this validation feature that does traffic validation, which is also really handy. So, like I was saying before, a really common problem that you have, particularly when working with this stuff at scale, is that the mock and the real API and maybe the open API spec as well will all kind of drift out of sync with each other.
Sure.
And the validator is there to kind of hold things together. So you can got any errors in here? I don't know. Nothing's gone wrong so far. If I try and make a dodgy request, maybe. What is it? Oh, I know why it's gone in there. Let's try this one. All right, better still, we'll do this one, and then we'll do a request that's not got anything interesting in the body. Hopefully that will return. Right, yes, there we go. Good. So it's generated a validation error. So I put soft validation on, which means it won't break anything, but it will just report to us in here. If I'd put hard validation on, that would have changed the response to an error. So that's what you do if you if you're running it in CI and you want to break your CI build kind of eagerly, then you put hard validation on. But soft validation just kind of reports this stuff in here. And as you can say, as you can see, because I didn't put any information in my request body, it's saying that these 3 required properties are not found. And the great thing about this is you can drill in and it will show you kind of exactly where in the open API spec the problem was.
This is so good. This is like a central view. I can create, validate, and then deploy. API definitions.
And you can actually, one other thing that's worth pointing out about this is you can use the open source WireMock library as a direct API client to WireMock Cloud. So the same wire protocol exists in both. So you can just say when you new up your WireMock object in your JUnit test or whatever, you can say pointed at this remote base URL instead of running against a local server, and then it will use WireMock Cloud as its sort of remote backend. And the great thing about that is you can turn the validation on. So if you've got code described mocks, and they can sometimes be hard because you've probably dried the code out, you've factored everything into these nice factories and so on like that. The downside of that sometimes can be recognizing when sort of an upstream change to an API needs to be reflected in your code changing and exactly where. Whereas the nice thing about this is that you can still benefit from the validator, and if the open API gets updated and that kind of invalidates the stubs you're generating in your code, then this can help tell you about it.
Oh my god! Okay.
All of this stuff is going to come to the CLI as well. So obviously this is all kind of cloud hosted at the moment. But what we part of what we're going to do with the CLI is to make it so that it serves as an agent kind of, or self-runner, depending on your definitions. So you'll be able to take this and run it on your laptop, or run it in a Docker in CI, or sort of inside your cluster, and still benefit from things like the validator while you're running all this stuff.
Amazing. I can't wait. This is the kind of stuff that people are. This is I can't keep saying this, but it is a game changer, kind of multiplier for productivity. As I truly believe having central dashboard. This is observability. That's what it is. It's observability for your ability to stand up, centralize, and deploy services. The idea that I can get that feedback, that I can visualize it, I can socialize it, I can say go to this thing, you can try it out. All these things people graft onto their existing. They build the API, and then everything else they have to figure out. And this seems like it covers all those bases for me.
Yeah, well, I mean, this is the thing. So much of this is kind of looking at what were people cobbling together themselves. So there was already an open API validation library. I think it was someone at Atlassian wrote this. That plugged into WireMock open source. Which is still out there somewhere that you can kind of do that with, but albeit you have to work that much harder to get the reporting information out of it. It's purely based around the open source library. People come up with all of these sort of workflows for collaborating on mocks, deploying them, hosting them, all of that kind of stuff. And the sort of original concept just came from going and looking at all these different organizations that were using WireMock, and they were all just building the same things over and over again. They were building this sort of layer of tooling around it all to allow them to use it at that kind of organizational level, to use it in that kind of outer loop kind of way. And this is really just a case of like, don't spend all this kind of engineering effort reinventing the wheel. Get your engineers working on the stuff that actually moves the needle on your business, and we'll do this stuff for you.
I love it. Well, on that bombshell, I think we need to wrap it up because it's just too productive. I don't think I can handle it anymore. But so for people who don't know, where do people? I mean, we just saw it's WireMock Cloud, but where any other coordinates people should know before we? So
WireMock.io for cloud. WireMock.org for open source. There's a community Slack which is linked to from both of those places on the header on both websites, I think, where you can come and talk to us if you want to. Lee and I both on LinkedIn, fairly easily locatable. I think those are all the main places.
I think so.
LinkedIn. Okay. Thanks everybody. Thank you. And thanks for everybody who hung out and asked great questions and so on. Okay. Goodbye.
Thanks again for having us, Josh. This has been
thanks, Josh.
Been great.
Thank you. It's Friday night in the big city, and you're hanging out with me on the internet. So that's dedication. I appreciate you. I really do. Thank you. Good night, everybody.
Thank you.
Good night.